Uh, Guys, can you see this board? Everyone, is this board visible?
सर अभी बहुतों ने ज्वाइन नहीं किए।
Okay, so let's wait for a few minutes. So can you please inform me in the group that there is a class today?
Yes, sir.
Good afternoon.
Good afternoon, sir.
Good afternoon.
Good afternoon, sir.
Sir,
Yes, sir. I1 I2 दोनों का ट्यूटोरियल है।
Yes, this is for both I1 as well as I2.
sir,
Yes.
sir, in the last class you have said that the cross wire should be between the lenses and the eyepiece.
Okay, I'll come to that point. उसको discuss करेंगे अभी.
Okay, sir.
Okay, so I think we should start. So there are some changes in the timetable. Now I'll take tutorial of both the groups I1 and I2 at this time. Okay, Thursday 12 to 1. So how much I mean I hope that relativity and thermal physics problems are already discussed in the previous classes. So did you solve some problem on these two topics?
Yes, sir.
Yes, sir. Devbrat sir gave those sheets for the assignment.
And what about quizzes? Did you submit
Yes, sir.
any?
2 quizzes were taken, STR and KTG.
Yes.
Okay, so on thermal you have already submitted one quiz, huh?
Yes, sir.
All right.
Sir.
Yes. Any doubt? कुछ पूछना है? So now we are going to start with geometrical optics. Okay. And I have already posted one tutorial in your file section. I hope you have seen it, right?
Yes, sir.
So in the tutorials folder, this tutorial, right? So we will come to this tutorial in a moment. Some of you have the problem with today's lecture, the position of crosswire, right? Okay, so let's invest 10 minutes on that and then we will come to this problem solving part. We are not discussing IPs right now. मान लीजिए IPs का केस नहीं है. This is something else. We just have 3 or 4 lenses in a line. We have one lens here, L1. One lens is here, L2. Say one lens is here, L3, and one is here, L4. Okay. And you have some object in front of first lens, maybe here, and when light pass through these 4 lenses, finally you get image at some point. Let us say this is the ray diagram. मान लीजिए रे डायग्राम कुछ इस तरीके का है. Okay. These lanes may be convex, concave. We don't know much about it. We are just making some rough plot. And I finally get image at this point. Okay. So the height of object is let us assume h, and the height of image is let us assume hs. Okay, this is image or final image. Okay. This is the object. This is a real object. If I ask you this question that I do not put anything here, there is nothing here. Instead, I put not same object, I put some other object here of a different height. Let us say this height is h1. Okay. What will be the new position of image? बता सकते हैं image कहाँ बनेगी? For h1 के लिए.
Same position.
Obviously, the image will not change. Image will still hless. If I put some object here, then where will be the image?
Same position, sir. They are all acting as intermediate objects.
Right. See, if I put some object at this new position P1, then you can see there is no change in the path of light. This object will emit the light. So the light will travel the same path as they were traveling before, right? So nothing is going to change if you put a new object at these positions. Let us say I put object at all the places. Here I put object 0, here I put object 1, here I put object 2. What will I see here? What do you expect here? What you will see? I have 3 objects placed at some particular positions. पहला ऑब्जेक्ट यहाँ रखा है, let me call it O0, इसका नाम O0 है. Second object O1 is placed here. Third object O2 is placed here. यहाँ पर आपको क्या दिखाई देगा?
We will see images of all the objects overlapping.
Right. As long as if these lenses do not have any aberrations, you will see 3 overlapping image, and all the 3 images are quite sharp as long as aberrations are not there. Aberrations नहीं होंगे, आपको 3 sharp image मिलेंगी एक दूसरे पर overlap करती हुई. Something similar is happening in the eyepiece. What is the concept of eyepiece? We have field lens here, big lens of eyepiece. We have eye lens here, the smaller lens of eyepiece. Okay, and we have some objective lens. Let us say this is objective lens. What is the ray path? So this is objective. This is field lens. This is eye lens, and finally we have human eye at some other point. Since final rays are parallel, it does not matter where is our eye. हमारी आँख यहाँ पर है, यहाँ पर है, या यहाँ पर है. It does not matter at all because the main target is to get parallel light rays. Okay. Light rays parallel नहीं होंगी, then it really matters where you put the eye. What is the ray diagram here? If we have some object here, then the ray path is something like this. Sorry. I'm just drawing some schematic. It may not be on the scale. I just want to show you how the things may look like. So if I put some object here, O0, which is real object, and if I put another object here of a particular size or shape, O1, then I will see overlap of these two images. And if all 3 lenses do not have any aberrations, the image of O0 and O1 will be very sharp and very clear. Okay. That is why we use a crosswire here. यहाँ एक crosswire इसलिए रखा जाता है so that when we see overlap of these two images, we can use this overlap to measure the size of object, right? But इसमें problems है. First, problem of aberrations. Aberrations का दिक्कत है. एक problem और है. This is the size of object H. But what size will you see? क्या आपको H का size दिखाई देगा यहाँ पर? The size that you will see, let us say that is H dash. Okay. Obviously, H and H dash are not same. It depends on how much is the magnification reduced by the setup. Let us say the magnification in object is 100 times. मान लीजिए object का magnification 100 times है. How do we get this magnification? Objective lens do not contribute much because its focal length बहुत ज़्यादा है. The main contribution is from field lens and eye lens. What about the magnification of eyepiece? Sorry, crosswire. क्या crosswire भी 100 time magnify हो रहा है?
No, sir.
The image of crosswire is magnified by the eye lens only, right? So aberrations का problem है. Not only this, there is a problem of magnifications also. If objects are getting magnified by different scales, it's not easy to do the calculations then. यदि दोनों का स्केल ऑफ मैग्निफिकेशन सेम नहीं है, तो मेजरमेंट से जो डेटा मिलेगा वो यूज करना बहुत आसान नहीं होगा। सो डेस्पाइट हैविंग वेरी गुड फीचर्स, बहुत सारे अच्छे फीचर्स होने के बावजूद भी ये आईपीएस हम यूज में नहीं ले पाते। नाउ लेट्स कम बैक टू ट्यूटोरियल पार्ट। इज इट क्लियर? जिसको डाउट था क्रॉस वायर का, क्या आप क्लियर है?
Yes, sir. Yes, sir.
Yes, sir.
So in this tutorial, did you guys solve these problems?
Yes, sir.
Any doubt anywhere?
Sir, can you please explain the procedure for finding all the cardinal points for the combination of lenses, especially the nodal points, sir?
So theory says for a particular case we are going to discuss here for pair of lenses. We derive three or four numbers. What are those numbers? A expression for second focal length, which is equal to the where small f2 is the focal length of first lens, f2 prime is the second focal length of second lens. Okay, so if capital small f2 is positive, it means we are actually talking about a convex lens, and if these numbers are negative, then it's a concave lens. Similarly, if after putting all the numbers, if capital F2 comes out to be positive, means this whole combination is going to work as a converging lens, means convex lens. If it is negative, it means that the total combination is going to work like a concave lens. We define other two numbers also, beta, which is df over first lens, alpha df over second lens. Using these numbers, how do we find all the 6 cardinal points? So first of all, we measure the position of principal point. How do we measure position of principal point? We measure it with respect to lenses, because lenses is the only thing we can see. So we first define the principal
Sir, can
point.
you scroll a little bit up?
Okay.
Yes, sir.
So let us say we have lenses here and here. मान लेते हैं यहाँ पे आपका फर्स्ट लेंस रखा है. Let us assume that we have second lens here. So this is lens L. ये आपका L lens था. This is the lens L dash. Where is H2? The theory says H2 is at this distance. पर ये कहाँ से measure करना है? This is with respect to second lens. Okay. Put all the numbers. मान लीजिए कैपिटल F2 पॉजिटिव है. Let us assume small f2 is also positive. It means beta is negative. Negative means H2 is somewhere on the left side of L prime. If beta comes out to be positive, then it is on the right side of L prime. So let us assume that here we get H2, means this distance is beta. And in this diagram, beta is a negative number. यदि बीटा पॉजिटिव आता देन वी विल ड्रॉ H2 ऑन द राइट साइड. Where is H1? H1 is at a distance alpha, but किसके रेस्पेक्ट में? First lens. Okay. So let us assume alpha comes out to be positive. मान लीजिए alpha positive आया है. Then go on right side. Let us assume you got H1 here. हो सकता है H1 यहाँ पे भी मिल जाए आपको. Okay. That depends on how much alpha you get. This distance is alpha, and in this diagram alpha is a positive number. Second, once we have defined H1 H2, they becomes the reference point of all the remaining points. एक बार आपको H1 H2 मिल गए, अब बाकी पॉइंट्स को आप इनके रेस्पेक्ट में कैलकुलेट कर सकते हैं. लाइक वेयर इज सेकंड फोकल पॉइंट? सेकंड फोकल पॉइंट कहाँ है?
F2 distance.
दिस इज F2, राइट? बट ये किसके रेस्पेक्ट में? ये फोकल लेंथ, ये फोकल पॉइंट कहाँ मिलेगा? ये मिलेगा आपको H2 के रेस्पेक्ट में. मीन्स let us say capital F2 is positive. So go towards right, F2 distance, and that's where you will get your F2. So let us assume you get capital F2 here. ये क्या है आपका? Second focal point. Okay. This distance is H2 F2. So let me write in words also. When we say 1 by F2, we actually means 1 upon H2 F2. Okay. Where is first focal point? First focal length कितना होगा पहले तो ये बताइए. Do we have any?
Then F2 to minus.
Now there are two answers for first focal length. First focal length कितनी होती है? Either you make the ray diagram in the same way we have made the ray diagram for when we drive this formula. जब ये formula drive कर रहे थे, we assume that lights are coming from left side, they are parallel and they get focused at capital F2. Make a similar ray diagram for first focal point. Light emerges from some point and after passing through both the lenses, they becomes parallel. Or you know by your experience that both the focal lengths are same in a particular condition. First focal length और second focal length same होती है, at least their magnitudes are same. कब? और they are opposite तो आपको हमेशा ही मिलेंगी. इस केस में जब लेंस के दोनों तरफ का मीडियम सेम है तब आपको ये दोनों फोकल लेंथ मैग्नीट्यूड में सेम होंगे बट दे आर ऑन अपोजिट साइड. ओके. मीडियम सेम नहीं है तब क्या होगा? They are opposite to each other, but they are not same in magnitude. Mod of F2 is not equal to mod of F1. Okay, but they have opposite sign. Opposite sign फिर भी होगा. So if one of them is positive, other one is negative. So since in all the real purpose case we usually have air everywhere, we follow this case. So like in this case, I am assuming that there is air everywhere. What is first focal length? In magnitude, it is same as this much, इतनी ही है, but with a opposite sign. So I assumed F2 positive. मैंने second focal length को positive माना था. It means first focal length is now negative. कहाँ से मेजर करेंगे आप?
H1.
So f1 is minus f2. कहाँ से मेजर किया जाएगा इसको? h1. Okay. So where is your first focal point? h1 से मेजर कीजिए. It is a negative number here. So go f1 distance in this side. Let us say we reach here. This is this distance, which is h1 f1, is precisely same in magnitude as h2 f2. Okay. What about nodal points now? Let me write nodal points somewhere here. So nodal points are also measured with respect to principal points. How do we find nodal points? By this formula. h1 n1 means distance of nodal point from principal point, or h2 n2 distance of second nodal point with respect to second principal point, is always equal to this. What is this value? If medium is same everywhere, they are just equal and opposite to each other. So if mediums are same, as long as both the focal lengths are same and opposite, what does it mean? h1 n1 is equal to 0, h2 n2 is equal to 0. ठीक? इसका क्या मतलब हुआ? जिसको आप h1 कह रहे थे यही n1 भी हो गया, जिसको आप h2 कह रहे थे वही आपका n2 भी है. In a particular case, like you filled this side by water, मान लीजिए आपने इस साइड में water fill कर दिया. Now what changes will you see? So here we have water, and let us say here we have air. Now h1 f1 is not equal to h2 f2. अब first focal length और second focal length same नहीं होगी, and h1 will not coincide with n1. h1 n1 coincide नहीं करेंगे, h2 n2 will not coincide. They will be at some distance. कितनी distance पर होंगे? This much. Okay. That's how we calculate all the numbers. Let us say we put some objects. Yes.
Sir, is it possible that we can sink the half of the combination in water and the upper half in air? What will happen, sir?
So you mean, okay, let me imagine what you are trying to say. So you are saying that the left half is in water, right half is in air.
No, sir. No, sir. Lower half is in another medium and upper half is in another medium. Then what will happen?
So this is like you are having two parallel systems. So the problem is something like this. Let us say you have one object here. Okay, let us say you have water here, you have air here. Just treat it like two independent systems. So instead of considering it as one object, you consider it like two objects, one of this size, one of this size. The images of these two will be at different positions. So when you see from this side, you will see half of the object at some other position, half of the object at some other position. And this is true also. When you try to see some object which is half in air, half in water, you realize that the object is just cut in between. जब आप ऐसे किसी ऑब्जेक्ट को बाहर से देखने की कोशिश करते हैं, आप देखते भी होंगे कि ऑब्जेक्ट बीच में से कटा हुआ दिखता है, राइट? So the images that you will get because of air, let us say the image is this, maybe here. Because of water, you may get image here. So since images are now being made at different position, you have changed the focal length. आपने focal length change कर दिया है. What you will see, आपको क्या दिखाई देगा? There is a cut in the object. Object में cut लग गया है क्या? Right?
Okay, sir.
Now, what is U here? मान लीजिए ये आपका ऑब्जेक्ट है, यहाँ पे भी एयर मान लीजिए. How do you define U? If you want to use this formula for location of image, what is V, what is U? सिंगल लेंस में तो U होता था आपका लेंस के सेंटर से इमेज तक की दूरी या ऑब्जेक्ट तक की दूरी. How do you define U here?
Distance from N1.
Distance of the object with respect to H1.
Yes.
And sir, V is distance of the image with respect to H1.
So U is measured with respect to H1. V is measured with respect to H2. So you can see there is no one center. जैसे single lens में था, lens is the origin. Now there is actually two origins. यहाँ पे आपके पास दो origin है, H1 and H2, and everything is measured with respect to these two origins. जितना भी object space है, that is calculated with respect to H1. जितना भी image space है, that is calculated with respect to H2. If object is here, what is U? Negative, right? If object is here, then object यहाँ पर है तब क्या होगा? Negative or positive?
Positive.
If object is here,
Then also positive.
Positive.
what about image? Image यदि यहाँ बन रही है तो
Negative.
Negative.
if you get image here,
Negative.
image यहाँ है तो
Positive.
second focal point यहाँ बनता है तो
Negative.
Negative.
second
Negative, sir.
second focal point यहाँ आ जाएगा तो
Negative.
Negative with respect to H2.
Negative.
Negative, sir.
Negative, sir.
here
Positive.
Positive.
तो you please wait. Remaining is F1. Let us say let us say F1 is here. क्या होगा?
Negative.
Negative with respect to
Negative.
H1.
Negative.
Now
Positive.
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 here
Positive.
Positive.
so now you understand the whole convention. Let us say N1 is here.
Sir,
Yes.
when we put the values of U and F2 measured with respect to H1 and H2 respectively, the value returned by V is by default in accordance with all sign conventions and measurement with respect to H2.
So let us say you get V is equal to some negative number. It simply means that your image is on the left side of H2 at a distance of 5 units. Okay. If you get V is equal to +5, it means that image is on the right side of H2 at a distance of 5 units. Okay.
Okay, sir. We don't need to do any additional calculation on V then.
No, nothing. So all the object space is calculated with respect to h1. जैसे u है, f1 है. These are calculated with respect to h1. All the image side are calculated with respect to h2. Okay. That is why I gave you this problem number 3. क्या लिखा है यहाँ पर? An object is placed at x is equal to 0. So we have one reference line. Let us say we have x is equal to 0 here. Some object is here. This is the object. Okay. A convex lens of focal length 20 centimeter is placed at x is equal to 30. Let us assume this is x is equal to 30 position. We have a convex lens here. What is the focal length? 20 centimeter. F is equal to 20 centimeter. Okay. It's a convex lens. Let me make a rough ray diagram. Sorry, rough image of a lens. Then we have a concave lens of focal length 10 centimeter at x is equal to 35. 35 means very close to 30. Let us say here we have that concave lens. So this is the concave lens. Okay. This is thick. Find the position of image using lens formula multiple times. प्लस 2 में आपसे प्रॉब्लम सॉल्व करने को कहा जाता है. How will you solve this? आप कैसे सॉल्व करते हैं?
Yes, sir. Finding intermediate image and treating it as object again.
Right. Or in some sense, you will use this formula 2 times, right? One time for convex lens, then another time for concave lens. Okay. So the convex lens will make some image somewhere. That image act like object for second lens, and then you get the final image. What is being asked here? Find the position by using your traditional method and locate that point. इस एक्सिस से पता कीजिए वो पॉइंट कहाँ पे था. Did anyone try?
Yes, sir.
बताइए क्या आंसर मिला है?
Sir, ये जो है 22.77 centimeter from the origin.
Just tell me the value of x. इस पूरी एक्सिस पर कहाँ आपको इमेज मिली?
Final image.
Yes.
22.77 centimeter.
So you are getting image on the left. ठीक है, कोई बात नहीं. Now second is first calculate the cardinal points. So there is some mistake. Obviously, sorry, because here is a concave lens. You cannot use the data of question number 2. It's a mistake from my side. I will correct it. So I forgot that in this problem I'm using 2 convex lens. Here I'm using 1 convex and 1 concave lens. So either you can ignore this part, or you can replace this concave part by convex. I think it's better to that you replace concave by convex so that you can use the data obtained in second problem as it is. Okay. Anyway.
Sure.
Yes.
In exam, like any kind of lens situation can be given. So
Right. So what is the second technique? You first find all the cardinal points. Locate those cardinal points on these axes. Let us assume you get h1 here, you get h2 here, you get f1 here, you get f2 here. Okay. Now what is u? अब आपको यदि इमेज पता करने के लिए कहा जाए, what your will be u? U is this value. कितना होगा ये? Some negative number. Why? Because if these all markings are correct, then you can see object is on the left side of H1. So this is U. Let us say this U is equal to -5. Okay. Let us say H2 F2 is equal to minus H1 F1 is equal to, just let me assume it's +10. I want to know where is the image. I will use this formula. 1 upon B minus 1 upon U is equal to 1 upon F2. Image I want to know. Position of object I know. At a distance of 5 units on the left. So 1 upon B minus 1 upon -5 is equal to 1 upon +10. What I get? 1 upon B is equal to 1 upon 10 minus 1 upon 5 means minus 1 upon 5, right? Minus 1 upon 5. Where is this image? Can you estimate? Can you guess? ये image कहाँ बनेगा? So this image is at a distance of 10 units on the left. किसके left में?
From the left of H2 के left में.
H2 से 10 units left की ओर बढ़िए, जहाँ पे भी आपका point आता है, that's where you will get the image. Whatever answer you are getting in 3A, same answer you should get in 3B. नहीं मिल रहा है इसका मतलब you have made some mistake. या तो आपने समझने में गलती करी है या कैलकुलेशंस में मिस्टेक की है. ओके कोई ऐसा है जिसका दोनों आंसर अलग अलग आ रहा है A एंड B पर?
सर मेरा आया था.
So did you find any mistake या
सर कार्डिनल पॉइंट में मिस्टेक हो गई थी सर.
So just recheck and yes, it's my error. I'll correct it. Do not either just replace concave lens by convex lens so that you can use the data of problem number 2. या फिर से cardinal points calculate कर लीजिए. Okay.
Sir,
Yes.
the procedure for calculating position of H1 and N1 is same irrespective of nature of lens.
Position of H1.
Yes, sir. That alpha beta. That is
See,
irrespective.
no. If you displace any of the lens, all 6 points will change their position. Okay.
सर यहाँ पे सिर्फ फोकल लेंथ साइन के अकॉर्डिंग यूज करेंगे ना. अगर कॉन्वेक्स कॉन्केव होगा तो जो सेकंड फोकल लेंथ है उसको माइनस रखेंगे.
माइनस रखना होगा, राइट. सी
यस सर ऐसा ही किया था सर, तो थर्ड वाला सर हो गया था मतलब.
राइट. सो
-10 से किया था सर.
one by one. If you displace any of the lens, it means you are changing all the cardinal points. Okay. So if you move any of the lens, let us say you just move both the lenses. Okay. Means D is fixed. D does not change, but you just shift the lenses. It simply means that all H1, F1, H2, F2 will shift by the similar amount. Let us say you change the separation between these two lenses. Then obviously, since you have made a new configuration, you will get new alpha, you will get new beta, you will get new focal length, and all your points will be new then. Cardinal points represents a system. If you are changing the system, obviously they are supposed to be changed, right?
Yes, sir. I was talking about that the lens is concave, so the procedure will not change.
No, nothing will change. Whether H1 is on left or right, that is determined by the sign of alpha. Okay. So let us say you have a concave lens. It simply means that in all these formula, F2 prime is now a negative number. F2 is small f2 is a positive number. Capital F2, I don't know. Do all this calculation. D is always positive. D हमेशा positive रहेगा. If capital F2 is a negative number, the whole setup is behaving like a concave system. If capital F2 is a positive, the whole setup is behaving like a कॉन्वेक्स सिस्टम। बीटा, मान लीजिए टोटल F2 इज आपका पॉजिटिव आ गया, कैपिटल F2 लेटर से इट्स पॉजिटिव, इट मींस बीटा इज पॉजिटिव इंटू पॉजिटिव डिवाइडेड बाय पॉजिटिव into a negative number. So beta is negative. Alpha positive positive divided by, नीचे concave lens रखा है, negative. So now both alpha and beta are negative. आपके दोनों alpha beta दोनों negative आ रहे हैं. क्या मतलब हुआ इसका? H2 is on the left of second lens. H1 is on the left of first lens. Okay. So procedure is not going to change. Formula यही रहेगा. आपके लेंस के टाइप के अकॉर्डिंग ये नंबर्स डिसाइड करेंगे कि आपके पॉइंट्स कहाँ बैठेंगे।
Okay, sir.
Okay, sir.
So fifth question. The fifth.
क्वेश्चन 5 से बता दो।
The space between the lenses filled with the water, find the focal length of combination of lenses. If you try to get exact answer, you will get a huge amount of derivations, and I think still you will not get any correct result. But under some approximations, you can get some meaningful results. क्या approximations है हमारा? Thin lenses. Or thin lenses simply means that the radius of curvature is much larger than the thickness of the lens. क्या मतलब है इस बात का? Let us say you have a lens of 1 centimeter thickness. एक लेंस है जिसकी थिकनेस 1 सेंटीमीटर की है. Will you call it a thin lens or thick lens? आप उसको thin lens कहेंगे या thick lens कहेंगे?
So that depends on the radius of curvature.
Right, that depends on the radius of curvature you are having. If lens is this, then even 1 centimeter thickness does not make any difference with respect to the radius of curvature. Let us say radius of curvature is 1 meter. Okay. If you have some lens of 1 centimeter thickness and radius of curvature is around 5 centimeter only, then the same lens, then it is a thick lens now. Okay. So the concept of thin and thick comes from the ratio of these two. Now when we have thin lenses, क्या benefit होगा हमारे पास? So we have one lens here, and let me just define it by a line because I am neglecting thickness of the lens with respect to size of lens. I will get some ray diagram. Let us say I have some object here, and for that object, the light ray, let us say this is the path of light. It is going in some direction. It strikes first lens, then it changes direction. Then again it strikes second lens. It again changes direction, and we may get image here. This is the position of image we finally get. See, the whole optics can be categorized, can be explained by using just only two numbers. वो दो numbers क्या है? I mean, how do you define the status of a ray? किसी light का किसी point पे status आप कैसे बताएंगे? Let us say you want to describe the status of light ray here. You just need to tell 2 points. क्या? What is the height of this point with respect to principal axis? And which direction is the light going? कितनी height पर थी principal axis से और किस direction में light जा रही है? Light is moving in this direction. How do you describe the direction? One simple technique is the angle made by this light with the horizontal. Let us say this angle is 10 degree. Height is, let us say, 1 centimeter. So now you can easily describe that at this point, light यहाँ से 1 centimeter की height पर, making 10 degree angle from the horizontal and going like this. Okay. व्हाट इज द रोल ऑफ दिस लेंस? लाइट के पाथ में इस लेंस का क्या रोल था? लाइट फॉल एट दिस लेंस एट सम हाइट. लाइट जब इस लेंस पर आई, वो किसी हाइट पर इसको टच किया. लेट अस से दैट हाइट इज 2 सेंटीमीटर. एंड इट हैज सम डायरेक्शन. कुछ डायरेक्शन भी था. कितना था? 10 डिग्री. बट व्हेन इट गेट आउट, जब इस लेंस से बाहर आई, हाइट कितनी थी? सेम 2 सेंटीमीटर. व्हाट इज द डायरेक्शन? क्या डायरेक्शन भी 10 डिग्री था अभी? नाउ न्यू डायरेक्शन इज समथिंग एल्स. लेट अस से -20 डिग्री, right? So what is the role of this lens? What is the contribution of this lens in the path of light? इस लेंस का क्या कंट्रीब्यूशन है इस लाइट के पाथ में? इट चेंज द एंगल. सिर्फ एंगल को चेंज ही तो किया है ना. चेंज द एंगल, चेंज द डायरेक्शन ऑफ लाइट, नॉट द हाइट. हाइट में तो कोई चेंज नहीं किया है. जिस हाइट पे लाइट आई थी उसी हाइट से लाइट आगे बढ़ रही है. सेम थिंग इज हियर. वही यहां पर भी हो रहा है. लाइट हिट द लेंस एट सम हाइट, लेट अस से 0.7 सेंटीमीटर. व्हाट वाज द एंगल ऑफ अटैक? किस एंगल से लाइट एंटर की है? -20 डिग्री. और किस एंगल से बाहर निकली है लाइट? लेट अस से -30 डिग्री, राइट? हाइट, प्रिंसिपल एक्सिस हाइट कितनी थी? व्हेन इट इंसिडेंट ऑन दिस लेंस 0.7, जब इस लेंस से बाहर निकली तब भी लाइट 0.7 की हाइट पर ही थी. सेम इज हियर. सो व्हाट इज द रोल ऑफ लेंस in this case? They just change the direction of light, change the angle, but it does not change the height. Okay. What about this? जो बीच में एक, let me call it slab of air. What is the role of this big air slab? इसका क्या रोल है? एनीवन? सो लाइट एंटर इनटू दिस स्लैब एट सम एंगल. किस एंगल पे एंटर किया? -20 डिग्री पर, राइट? लाइट एग्जिट फ्रॉम दिस स्लैब एट सम एंगल. किस एंगल पे एग्जिट हुआ? सेम -20 डिग्री पर. लाइट किस हाइट पर एंटर की थी? 2 सेंटीमीटर, राइट? लाइट किस हाइट पे बाहर निकली है? 0.7 सेंटीमीटर, right? Or I can say that the role of this air slab is no change in direction of light. Light की डायरेक्शन को तो ये चेंज नहीं करता है, but yes, it changes the height, right? Now what we have done, प्रॉब्लम में हमने क्या किया है? We fill the space with water. Lenses as it is है, so lens का रोल भी ऐसे कैसे ही रहेगा. We have changed the role of this air slab. देखते हैं क्या चेंज आया इस एयर स्लैब के रोल में. So earlier we were having a slab of air. शुरू में हमारे पास एयर का स्लैब था, राइट? Of length d, जिसकी लेंथ d थी. Light was getting into this slab at some angle. Light किसी एंगल से स्लैब के अंदर जा रही थी और उसी एंगल से बाहर भी जाती है. How much angle was it making from the horizontal? Light ने कितना एंगल बनाया था हॉरिजॉन्टल से? This theta. Let me call it theta I. और ये एंगल भी थीटा आई होगा, राइट? जब लाइट बाहर निकलती है ऑब्वियसली सेम एंगल, तब भी सेम एंगल ही बन रहा है हॉरिजॉन्टल से, थीटा आई. नाउ व्हेन यू फिल this air slab by water, जब आप इस स्लैब में वाटर भर देंगे, what angle will light make from the horizontal? Theta I, less than theta I, or more than theta I?
Less than theta I.
So this new ray is this. Since it is a denser medium, light will move towards the perpendicular, and this is the new direction. Okay. What is this new angle? Angle of refraction, theta r. Okay. In the previous case, height में कितना change आया? Light incident on h height, light get out on h dash height. कितना change था पहले? h minus h dash. How much is h minus h dash? ये distance आपका d है. Initial angle was theta I. So tan theta I was h minus h dash upon d, or h minus h dash is equal to d tan theta. Okay. Now, because of the water, light will cut at some other height. Light जब लेंस पे गिरेगी तो किसी और height पे गिरेगी. Let us say that height is h double dash. कितना change हुआ height में? h minus h double dash is equal to d new angle. अब जो नया angle है tan theta r, right? दोनों में कोई कनेक्शन है थीटा i और थीटा r में?
Sir, Snell's law.
Right. Or if these angles are small, these are nearly equal to tan theta I upon tan theta r, right? So I can say this number is nearly equal to d upon n. N is the refractive index of water, tan theta I. Okay. So what is the role of this water? Water का क्या role था? It allowed the light at some other height. इसने लेंस 2 पे जब लाइट जिस हाइट पे गिर रही थी उस हाइट को बदल दिया. ठीक है, कोई बात नहीं. Let me consider another case which is slightly different from this case. क्या केस है वो? Let me move it on right side. इसको राइट में मूव करते हैं. I am considering again air slab. मैं फिर से air slab consider कर रहा हूँ. But now I am going to change the width of this air slab. इस एयर स्लैब की विड्थ को मैंने कम कर दिया. कितना कर दिया इस बार मैंने? d अपॉन म्यू, सॉरी d अपॉन n. लाइट सेम h हाइट से इंसिडेंट होती है, सेम थीटा i एंगल से फॉल करती है, एंड दिस इज एयर. ये एयर है. ओके. सो दिस एंगल इज थीटा i. जो एंगल हॉरिजॉन्टल से बन रहा है थीटा i है. बता सकते हैं लाइट किस हाइट पे बाहर निकलेगी? h डैश, h डबल डैश, या कोई तीसरा ही नंबर हो जाएगा इस बार?
No, sir, something different this time. D by n square into tan theta.
You have all the numbers in front of you. Let us say it is h triple dash. Then what you will have? H minus h triple dash is equal to d upon n tan theta I. कहाँ देख रहे हैं ये नंबर आप इस पूरे सेट में?
फर्स्ट वन.
Right? So h double
Yes, sir.
is h triple dash, or you can produce the same effect by air slab also. Air slab से भी same effect produce कर सकते हैं. If you choose length of air slab is equal to this. Means इसका क्या मतलब हुआ? A water slab of thickness d, d thickness का water slab, और d by n thickness का air slab इक्विवेलेंट है. ओके. सो वाटर के प्रेजेंस के लिए मुझे दोबारा से सब कुछ ड्राइव नहीं करना है. I can directly get the answer. कैसे? Just replace d by dy then. Okay. And instead of d, now I will use d upon n. That's it. Remaining things are not going to change. बाकी तो कुछ नहीं change होना है. The lens are working in the same manner as they were working before. Is it clear?
Yes, sir.
Right?
Thank you, sir.
Sir,
Yes.
so the d by n is the air equivalent of the water slab.
Yes. So instead of doing the whole ray diagram again, पूरा का पूरा ray diagram दोबारा बनाने की बजाय, we just find the air equivalent of the water. Means all we want that the light should fall on lens 2 at the same height, at the same angle as it were falling in the presence of water. जैसे water की presence में जिस height पे fall कर रही थी, जिस angle पे fall कर रही थी, उसी angle उसी height पर air की presence में fall कर जाए. We need to find that corresponding thickness. Once we get that thickness, our purpose is solved. Okay. So with this, let me stop. Any other doubt? I think remaining problems are quite easy.
Okay,
Sir,
sir.
please, sir, can you please upload the answers of the not complete solution, but final answers. Or whether
All
we are
right. Okay. Okay.
Okay, thank you, sir.